Hey everyone, I'm Sean from Team Thagomizer, and welcome to the first of a couple of videos on the building of my 12-pound robot, Minimizer. To start off with, I want to focus on the most important part of the robot, the drive system. Minimizer was a robot very much designed around the drive system. I probably spent about 50% of the time of the entire development time of this robot purely designing these drive pods. And that's for a good reason, I think, because personally I think that the drive system is the single most important part of the robot. If the wedge gets damaged, if the weapon breaks, it's annoying, but on a Thagomizer style bot, you still have the other end to work with. With the drive system, if that fails, you're toast. You can't move, and you're going to get counted out. So, whenever I try to design something, I always find it helpful to first list out exactly what I want the system to do, as it's way easier to make changes early in the design process. So for Minimizer, there were a couple things that I thought were really important. First, I wanted the entire system, or the entire drive system, to be replaceable in under a minute. I wanted the entire thing to scale well into higher weight classes. I wanted to be able to isolate the motor from shock in all directions. I wanted the entire system to function as armor rather than being a potential weak point. The system has to be invertible and be able to turn the entire robot 180 degrees in under a second. And lastly, I wanted to be able to do all of this without having to use any machining or CNC. Okay, so let's take a look underneath the hood of Minimizer. So first we need to take off the main axis hatch. Okay, and with those 4 screws we can just remove the top and we can see the main electronic compartment of Minimizer. As you can see, it is a total mess. This is definitely something that I want to improve in the future, and currently it is a very melty PLA enclosure that's trying to keep a whole bunch of spaghetti inside. So ignoring that, let's go on to the method to remove these drive pods. So, they're super simple, and I'm not even going to fast forward through this because of how simple it is. You simply undo that and take out these big bolts. So that's something that I was not 100% sure on, is are these bolts actually strong enough to not get completely destroyed if I get hit? They're pretty thick, so these are M8 bolts, and I think they have an approximate internal diameter of maybe 5 millimeters, which should be enough. They're made out of hardened steel, so they are fairly strong. And I did take a couple hits to the wheels during my fights at Norwalk, and they did not break. So, so far it seems like they more or less do the job okay. So with this last screw, we can take the entire drive pod out. Alright, the only thing we do need to do is then also remove the, unplug the ESC wires. So just got to come into this mess and pull on a couple plugs, and ta-da! That is the entire pod. With a bit of fidgeting, the entire thing should come right out. And there we have it. This is one of the drive pods of Minimizer. Okay, now that we have the drive pod out, let's talk about its main features. So, based on my key features that I talked about earlier, the reason for the mounting system was to get to that 1 minute mark. So, it's a bit tough to do it by yourself, hit a minute, but with the tools in hand, it is definitely possible. And that allows me to really stress a lot less in the actual competition, because rather than having an entirely separate robot, which many people do in small weight classes, and BattleBots actually, that's a lot of money, having 2 robots. So this system allows me to, rather than having an entire new robot, I have individual drive pods. So I can take a new one, slap it in, takes a minute or 2, and then I don't need to worry about repairing that then and there. Of course, later on, if I find time in the competition to actually repair these things, that's also an option. The second key requirement for the drive pods was that they'd scale well into higher weight classes. So rather than try and completely reinvent the wheel, I decided to take a look at some of the existing heavyweight setups. A lot of the inspiration for this drive system actually came from Team Copperhead, so they run a very similar intermediary drive setup. The difference is that they run chains across both of these reductions, whereas I use a gear on the outside and a pulley on the inside. The reason for that is that, one, chains don't scale well into 12 pounds, and two is that the large gear on the outside allows me to better absorb hits, as well as be more resistant to foreign debris. And then on the inside I have belts which help reduce any shock that might travel down through the power system into the motor. Additionally, gearboxes are quite heavy, so they have a lot of weight in their reduction, which I can put, rather than having it all in the housing and the many tiny gears within one, I can put a lot of that weight into really armoring up this pod. So over here I have a 3mm plate, which is actually the same thickness as the wedge on Thagomizer. So not only would someone, in order to damage this drive system, have to go through the really thick wheel, but this entire pod is also incredibly sturdy. Now let me take one of these things apart and then we can assemble it together. So here we have all the parts that compose the Minimizer drive system. So let's start with the motor. Minimizer runs a 4238 750 kV motor for its drive. This thing was really overkill. It's really something that's designed for 30 or even 60-pound robots for their drive systems, but I decided to stick it into Minimizer because Minimizer really does depend on its ability to turn, and its ability to turn is directly linked to how powerful these motors are, if I had the traction that I needed. I really didn't have the traction that I needed. That's something that I need to improve in the future, but this thing is just really just too powerful, so I'm probably going to be switching this down to a slightly small motor in the future. So next, onto this goes the pulley. So this is the pulley, the smaller pulley for the belt on the inside. That's something that we definitely forgot to do before the competition, was actually grind in these flat spots, which led to quite a few issues. These pulleys kept on slipping, so in the middle of the competition we got out a Dremel and just ground down these flat spots. Without them, it's too powerful, there's too much torque, and these set screws are just going to give up every single time. So let me screw this on real quick. Okay, so now that the pulley's on, let's switch over to the shock mounting of the motor. So let me assemble that first, and then I'll go over its features. Okay, now that that's assembled, let's talk about the two halves of the motor mount. So on the outside, we have 3 M5 screws that go through the assembly. There is a PLA spacer combined with a TPU shock absorbing layer. On the inside, we have another TPU layer, and that is sandwiched between the motor and a 2mm 6061 aluminum adapter plate. So this adapter plate, as you might be able to see, is actually completely bent. That's an issue that we ran into at the competition, where despite this entire thing being on the inside and far away from impacts, it still got bent. So that's definitely something I'll have to improve in the future, maybe switch to a 3mm plate or to a material that can absorb a bit of this energy without permanently deforming. So once we have these together, we can simply stick them together like this, and that's the completed motor mount. We'd have these 3 M5 nuts that go on the end here, though that was another issue that we found in the competition, is that these things can be kind of a pain to put on in the middle of a competition. It's okay when you're relaxed and you're just at home assembling these things, but in a stressful environment like the pits, and you've got to get the robot done in the next 5 minutes or you're going to get disqualified, it gets stressful, and then you're trying to stick one in here and it falls out, it gets stuck inside these motors because these are all magnetic, of course. So this is something that definitely needs to be revised in the future. So now that we have that done, first we have to actually put on the intermediary shaft. So the intermediary shaft, it consists of a couple components. So we have this stainless steel D shaft that goes through the plate. This is something that definitely needs to be changed in the future. I went with stainless for this just simply because I could find it, though I know that I can get this made out of the same 4130 chromoly that everything else is made out of, and that'll make it easier to both weld it, and after heat treatment it should also be much stronger. So these go in through a bushing that's on here and then through the plate. On the other hand, we have a printed pulley, and that simply slides over like this. Once we have that, we simply have to screw it all together, and there we go. So that's really all there is to that. This is a part I found online. It's actually from the same company that made the shaft, so it made it easy to buy and slot together. In the future I might be able to machine something like this myself, but as I said, this entire thing was built without any CNC or machining in mind, so I went with off-the-shelf parts for this. So next we just need to slide this belt on. Okay, and now that that's on, you can see that this transfers the torque quite nicely. So let me get these nuts on and I'll catch you in a second. Okay, so this last nut is just simply not getting on here, so we're just going to move on to the wheels. Before we go on to the wheel, let me actually take a second to talk about the drive plates themselves. So there is a 3mm 4130 plate that really composes the backbone of each of these drive pods, and the entire thing has been tempered and heat treated. So there's actually two plates, so there's the main plate and there's a secondary smaller plate that you can see here, though it's underneath a whole bunch of welds. And that's really just to reinforce the area around the holes and the shafts in order to make sure that there's less torque on those actual components. At the very end of it is welded a weld nut, and that keeps the entire thing together. Okay, so the wheels. So here we have one of the wheels of Minimizer. These things are probably the strongest part of the entire robot. They're absolutely bulletproof. You can see here, at least this wheel has taken at least a couple hits from either I think it was probably Carmen, and apart from really small little flakes coming off, they're still perfectly fine. They're really a fusion between Team Copperhead's massive urethane wheels and Calvin Eber's wood magnets. So you can see here there's a titanium ring that goes all the way around, and on that are some spikes. If I hold it up to the camera, you can hopefully see them. These have actually been ground down. In the fights against Demogorgon, his undercutter came underneath the wheels and shaved a lot of these off. So this one's probably going to be retired after this. So on the inside you can see the gear that really drives the entire thing. Once again, this is 4130, again heat treated, and we've got 3 M5 bolts that really go the length of this entire thing. On the inside there's 2 needle bearings, and that helps ensure that the entire thing rolls smoothly. There is a nylon core on the inside, and the outside is probably an inch thick urethane. This stuff as I said before, it's incredibly tough, and I've yet to see anything go through it. So, now that this is all together, we can simply slide this over here, and one of these bolts simply drops right through. It can be a bit of a pain, but there we go. And we simply tighten this to start off with, and then grab something big and torque it all down. So this is also a 10mm diameter hardened steel shaft, so they're really strong. I'm not sure if you can see it, but it did actually get hit by something, but just really minor damage. That's the reason actually that these bolts are recessed, is that the urethane is able to help deflect and keep blows from actually hitting this shaft. Because as strong as this entire thing is, there is a lot of torque from if you get hit here all the way to the actual mounting point here. So I really wanted to try and avoid that. So this way, really any foreseeable angle that a weapon can come in, it first has to go through 1.5 inches of urethane and then strike the bolt with enough force to actually break something. So it hasn't happened yet, and I kind of doubt that'll happen in the future. So there we have it. That's one of the complete drive pods of Minimizer. And yeah. So that was a quick overview of the Minimizer drive pods. If you have any questions, feel free to leave a comment down below. I'll be releasing a new video on the weapon system as well as the electronics soon. Until then, I'm Sean, and I'll see you later.